mentioned, cylinders is what we're focusing in on today. So, overall, when it comes to our three-dimensional solids, prisms
Someone took your pamphlet sheet, didn't
I got it back. I knew who had it. She just had it for 2 days in a row. Prisms and pyramids actually tend to be the most challenging. They tend to be the most challenging because of the fact that there is that capital P, that capital B, the perimeter and the base area that you need to be finding. Those are what make things the most challenging in these problems. Furthermore, the fact that pyramids have that slant height tends to cause challenges because it has two different heights. When we get to our non-polyhedrons, our three-dimensional shapes that have some curve to them, those ones tend to get a little bit easier. Now, some like the cone are still going to have both a true height and a slant height, but in the end, still going to be easier to work with. If you do not have a calculator, you are going to need to grab one. I still see desks without calculators. But otherwise, in your notes packet, open up to page 10. So, getting to our cylinders today. Y'all know what a cylinder is, right?
Yes.
How many bases does a cylinder have?
0.
2. What shapes are the bases?
Circle.
They're circular bases. Specifically, a cylinder is a solid formed with two congruent and parallel circles. Now, given that these circles are congruent, by definition of congruent circles, which we haven't talked about yet, but it's really, really easy to understand, these circles are going to have all of their measurements the exact same, i.e., the radius is the key one. The radius is the same in this circle versus that circle. Now, the circles are the bases, which means the lateral is that curve around. And when I unfold my cylinder, the lateral face just makes one big ol' rectangle. Now, if it was not a cylinder that looked like this, if it was a slanted cylinder in any way. Now, to be slanted, that means the base and both bases still have to be congruent. It just means that they're not directly above one another. Looks something a little more like that. But if it was a slanted one, it would make a parallelogram instead. But wait a second. Isn't a rectangle a parallelogram? We should know that by now. We've been using the parallelogram formula to find the area of the rectangle. Now, what this means is our lateral area can be found by finding the area of said rectangle. How do you find the area of a rectangle? Base times height. Base of the rectangle. I'm going to make it that big long distance. When I curl it back up, that big long distance goes here. Goes around the circular base. What is the distance around a circle?
360.
What's it called? It's got a name. It's the circumference. So, the base of the rectangle is the circumference of the circle. The height of the rectangle is the height of the cylinder, because cylinder height is the distance from base to base, just like a prism. Which means it is not always going straight up and down. If I hold my prism or my cylinder like this, my base is going, or sorry, my height, let me try that again. My height is going here from base to base. What's that mean? Well, that means lateral area is equal to, okay, circumference. How do I find the circumference of a circle again? If only I had a formula sheet with circumference on it.
2 times pi times r.
2 pi r, that's the formula we want. There's also pi times diameter, but we don't generally do that one. 2 pi r represents the base of the rectangle, and the height of the rectangle is the height of the cylinder, which is given by h. R is the radius. H is height of cylinder. And remember that that height goes from base to base. It has to be perpendicular to the bases. That's that key thing. And therefore it goes from one base to the next base.
Whenever I write my r's, it looks so steep.
I cannot help you with that. Okay, as a result, overall surface area. Just like the others, it has 2 formulas, but generally we're not going to use both formulas. Surface area is lateral area and surface and base area put together. How many bases did we say the cylinder had? 2. So 2 base areas plus the lateral area. How often are we using that formula? Not often. About the only time that that one is helpful is if you're given the lateral area. Furthermore, if you're given the base area. Because unlike the other shapes, I don't have to calculate the base area of a cylinder separately. We had to do that with prisms. We had to do that with pyramids because the base of a prism or of a pyramid changed from prism to prism. But the base of a cylinder is always a circle. Therefore, that base area, we can actually put a formula into it. So the 2 is still involved, but how do you find the area of a circle? What's the formula? So instead of doing a capital B, I can do pi r squared plus lateral area, we said was 2 pi r h. What kind of units go on surface areas and lateral areas? Squared. Volume. There's 2 formulas for volume. A cylinder is most like a prism. The only reason it's not a prism is because prisms require polygon sides. It requires straight edges along the entire thing. Now, as a result, that means one of the formulas for volume could be the exact same as that of a prism, base times height. But didn't we already establish the base is always the same shape? So instead of doing base area, it makes a lot more sense just to say the base area is a circle area, which is pi r squared. and it gets multiplied by H. What kind of units go on a volume?
Cubed.
Units cubed. Much like surface area, we will likely never use that formula for the volume of a cylinder. The only exception is if I give you the base area outright. So, find the volume and surface area of each solid, round your answers to the nearest hundredth. Okay, first thing you do is you recognize the shape. What shape? I'm fairly certain it's a cylinder as well. Therefore, surface area formula is 2 pi r squared plus 2 pi r h. It's an ugly looking formula, but it's actually one of the easiest ones to use because you don't have to calculate anything first in order to go into it most of the time. There's one tiny exception and we'll talk about that. Volume, pi r squared h. Again, one of the easier formulas because you don't have to calculate anything ahead of time. As long as you know r and as long as you know h, you're golden with these ones. R is the radius of the base specifically. Do we know the base's radius? Yeah, what is it? 9. H is the height of the cylinder. Do we know the cylinder's height? Yeah, what is it? 6. Specifically, this is the height because why? Connects the bases specifically perpendicularly. Okay, so 2 pi times 9 squared plus 2 pi times 9 times 6. Ugly formula. But guess what? Calculator friendly. You just have to type the entire thing in.
Now, would you type it in 2 pi without putting the... Okay. I was just...
It does not matter either way. I personally wouldn't have put the times in there.
There's more work.
Because it's more work. Exactly. But I do need to put the times between the 9 and the 6. And between the pi and the 9. On both of these. Otherwise it has issues. These ones you will always need to round. Because of pi being an irrational number, meaning it's got a decimal that goes on forever, there is no way that this is ever going to turn out to be a nice number. Rounded to the nearest hundredth, 848.23 units, feet squared. Volume, same idea. Shorter formula. Pi, I have to put the times here, Gesundheit. 9 squared times h we said was 6. Shorter formula, also very calculator friendly. $1526.81 feet cubed. Not so bad? Okay, some people are still writing. If you are not one of those people, I would be taking the time to add this formula to your formula sheet. can also add that later. I just, since we had a minute while people were still writing, wanted to add it. Okay, find the volume and surface area. Same questions going on. Is that a cylinder?
Yes.
Sweet. By the way, starting in this section, you are going to start to see different shapes mixing together on your homework assignments. So you need to pay attention to what shape it is still. Do you have to write it down every time? No. Do I recommend you write it down? Yes. What's that surface area formula again? One of the most common mistakes I see with cylinders is people missing the squared on the first part, putting the squared on the second part. Keep an eye on where your squared goes. And volume, pi r squared h. Do we have r? Not directly.
It's 6.
Where are you getting 6 from?
Half of the diameter is always a radius.
Yes, this is the diameter, and remember the diameter is 2 radius, so if I have that, that'll give me my radius of 6. Do I have the height? Yes, it is 10. Thank you. So, 2 pi times 6 squared plus 2 pi times 6 times 10. Ta-da. Nate, what do you get? You're gonna have to start typing it into a calculator. There's no way you're doing it in your head with pi involved.
What's the radius?
Dude, I literally have the entire thing right here.
Wait, no, I thought I was doing that.
No, this. While he's doing that and typing that in, Jocelyn, what's this formula gonna look like with the numbers plugged in?
It's 603.1 or
1.9. Dominic, what kind of units are gonna go on that surface area? Good. Haley, what do we get for volume? Greta, units.
Oh, wait.
Cubed. And don't forget to put the meters first. Try out the next one on your own. I'm going to do it quickly up here and come around and check how people are doing. So you need to actually do it. Those of you who are staring off into space. Try out that last problem. Well, not last. You've got the 2 at the bottom, but you know what I mean. Connor, what's the radius of our cylinder? Dude, you were doing it right. Yes, you do.
Was that?
Yes. What's the radius? Coming back to you on one. Lily, what's the radius?
24.3.
24.3, because that 48.6 is the what?
Oh.
Diameter.
I heard you wrong. Yeah, I got it.
I know you did. Charlie, what's the height of our cylinder?
8.7.
8.7, so be careful. Height does not always go up and down.
Oh, bad juju. Oh.
5,038.49 and 16,139.19. Most people had gotten this already. We got two final problems left. These are the working backwards problems. Now, just like the ones where you're working forwards, finding surface area, finding volume, the working backwards problems, you should first identify the shape. What shape?
Cylinder.
These are both cylinders. Now, we identify the shape because that tells us our formulas. That is always what we need to recognize first. Because if we're using the wrong formula, it is guaranteed to have problems. So, Trey, which formula makes more sense to use this time? The bottom one. Because what I'm given is V, which means I'm not given enough information for that one. So, 3,769.91 equals pi is still pi. Connor, what is the radius of this cylinder? It is just x. So when I do radius squared, it's x squared. Aiden, what's the height of this cylinder? 12. The nice thing about the cylinders, when you calculate volume and surface area, is also the nice thing about the working backwards problems. I don't have to pull off the base and calculate things separately. When I'm working backwards, I should be able to just simply plug the things in where they belong. Now it's just a matter of solving this. Vivian, what do you believe that we should do first in solving this? Divide by 12? That is one option. I'm going to do this two different ways. So, first way, following Vivian's lead. I divide by 12. Ava, if we continue going that way, what should we do next?
Probably
Divide by pi. Oops, did I actually divide that by 12? Don't forget to actually do the divide. Struggle bus moment for Benson. Okay, over there should be 314.16, and now I'm going to divide it by pi. By the way, if you just do divide by pi right here, it's going to make it where you didn't have to round. But you might get a slightly different answer. That being said, what are either of those going to round to? 100. 0.00, aka 100. Riley, what comes next? Take the square root. To get rid of a square, you take square root. Now, generally, when you introduce a square root, there's something else you actually should introduce to the problem as well. Do you remember what symbol? Plus minus. But does it make sense to have both a positive and a negative?
No.
Not when it's a radius. X is equal to 10 feet. Now, the other way to do this, the more traditional way, simplify this stuff first. What can I actually simplify on that side of the equation when I still have my pi times x squared times 12? What's just numbers?
12.
And
Pi.
pi. Traditionally, you would simplify the 12 times the pi. You'd get 37.70 x squared, and then you would divide by that. You would still end up with 100 equals x squared, and therefore x is 10. Do you have to do both ways? No. Do I care which way you do it?
No.
Not really.
As long as you get the right answer.
But the reason that I show you both is because of the next problem. We already established this was a cylinder. And therefore it uses those two formulas again. Colin, which one do you think I'm going to use this time?
What do you mean?
Which formula?
Oh, we're gonna use the S.
Why?
Because that's what's given to you. They don't give you the volume.
Correct. They give you surface area. So, 251.33 equals 2 pi times, do we know the radius?
Yep.
4 squared plus 2 pi times 4 times, do we know the height?
X.
X. You have to be careful when you're solving your problems. You have to simplify things when the problem gets more complicated. The surface area formulas on these ones are going to get the problem to be more complicated. So you want to simplify things. Being careful not to combine unlike terms. One of the common things that I saw in your quiz, which I don't have your quizzes fully graded yet. I've got half of your class's back page to go. I'll have them done tomorrow, I promise. I just didn't get to it this weekend. But one of the most common things that I saw on the last two problems of your quiz was people combining unlike terms. Because when there's addition involved, you have to be careful. When there's multiplication, it's not a big deal. You can multiply unlike terms all you want, but you cannot add unlike terms. So, first thing I should do is simplify this. That side doesn't simplify, but this simplifies, and this simplifies separately. 2 pi times 4 squared is 100.53. 2 pi times 4 times x will be plus 25.13 x. You simplify the numbers, the x's just stay where they belong. How do I go about solving this?
It will be, since that's addition, it will be 100.53 minus 251.3.
You said it backwards, but right idea.
Oh.
Subtract the 100.53, which is I think what you meant.
Yeah, yeah.
$150.8 equals 25.13x. To finish it off, we would divide. Rounded to the nearest hundredth, x will be. I like when it's got lots of zeros because that just means it's 6. Technically 0.00, but 6 miles That's it for notes today.
I like this one.
Yeah, cylinders tends to be easier. Okay, it was mentioned earlier, but what's happening this week? Test. So, do make sure that we're getting our homework done and turned in this week.